let's try to accumulate people. There's no operator plus defined for people, so it's not going to work. But that's good. That gives us an opportunity to write a specialization. Here's our accumulator class, as we saw at the end of the last demo, and you may have already noticed that person is already in this project. I'm going to paste in some code because watching large quantities of typing is never entertaining. And this code works because there's an include of person.h here also. So you can see that I'm going to declare a sort of a dummy person. The first name and last name are both quotes, and the arbitrary number is 0. This can be our start. Now, whether we define adding people to mean tacking all their names together so that Kate Gregory plus someone else is Kate someone Gregory else, maybe these are our employees and arbitrary number is their salary, and I want to figure out our total salary burden, so I'm going to add up everybody's arbitrary number. It's probably a better way of thinking about it. Either way, I've got this sort of dummy person, and then I'm going to make an accumulation of persons called people, and I'll use that dummy person as the start because the starting value needs to be of the type of whatever it is we're accumulating. Declare a couple people and stick them in, just exactly in the way that we declared an accumulator and plus equaled them into the accumulator of strings. We'll plus equal our person objects into the accumulator of persons. And then people.getTotal will give us a person. We can use the dot syntax and call whatever member variable we want on it, like getNumber. It makes sense, but when you go to build it, and I'm just using the keystrokes here, error messages like you wouldn't believe. Now, there are an awful lot of them, but what they basically boil down to is the plus. Let's scroll out this way. I couldn't figure out what to do in order to handle the plus equals when I wanted to accumulate these person objects. Interestingly, it's only going to complain on these two lines. If I comment out these lines and then build, the build succeeds. The compiler has no objection to me declaring an accumulator of person objects. It has no objection to me trying to call the getTotal member function of that accumulator, and it knows that getTotal will return a person, so I can call getNumber on that. All of this is great. The only part it didn't like was the plus equal. And the reason it didn't like the plus equal, because person, for all the operators and goodness that it has, does not have an operator plus, does not have a way to add two person objects together. Now I have 3 opportunities as a developer to try to solve this problem. One is I could say, you know what, I don't need an accumulation of person objects to figure out their salary burden. I'll just make an accumulator of int. And then I'll go through my people, and instead of adding a person, P1, into my accumulator, I'll call P1.getNumber, and I'll put the resulting integer into my accumulator. It's okay. It might be repetitive. You might have to type .getNumber a lot, and you're sort of pulling some of the business logic about a person out into this calling code. You have to know to call getNumber. You're also, of course, giving up type safety. People can put any old integer into that accumulator, and the compiler will let them. Whereas when we have an accumulator of persons, we have that type safety that people can't put anything else in there. Imagine even a very generic loop. If it has to write different code for persons by calling getNumber, that's kind of awkward. So a generically written loop would be tripped up by the fact that, oh, but for persons we can't use the accumulator. We have to remember to call getNumber. So let's rule out that possibility. The next choice is that I could write plus for person. I have person.h right here in my project. I could totally go in and write the plus operator for person. I could write a free function for person that constructs a new person that's somehow bigger based on the arbitrary number of the person I'm adding it to. It'd be a little bit of a challenge. There is no public set name function in person, so I don't know how I'd set the name of the new person. I could use get number and set number, that's all fine. Kind of awkward. What I want to show you, and what is in many cases the only approach that will work, is to write a template specialization for a CUME that says, here's how you handle the special case of person. The first time you find a template not working for you, you may find a bit of a workaround, the equivalent of calling get number and then, oh yeah, it works great with ints. That's fine. You know how to call a member function. I don't need to spend any more time on that. The second time you find a template that doesn't work for you, maybe you find a workaround by writing the operator as a free function or by going into the class and writing the operator. That's a good choice, especially if having that public operator anyway has other value in your program. But the day is going to come when you want to use a template, maybe even a template that you wrote. It doesn't work with your class. There's just no workarounds. You can't write the operator because it's already written and you don't want to accept what it does, and you need to write a template specialization. It's not a hard thing to do at all, so let me show you. In fact, in the case of accumulator, we gain a real benefit by writing a specialization, which is that we can actually change the type of our running total while we're at it. So let's go into accum.h, and I'm just going to copy all of this and put it here. When you write a specialization, the brackets here become empty, but they don't go away. You still say, I am writing a template. That way, the compiler, when it goes to do the template instantiation, looks at this one too. And here, I say, this is the specialization for person. This is how you write an accum of person objects. And now I have no more t placeholder, so I need to take it away. Most of the time, you run through and just mechanically change t to the type you're writing a specialization for, which would be person in this case. But, you know, it doesn't really make a lot of sense for the running total of my person objects to be a person. The name doesn't mean anything. So I'm actually going to take an opportunity here and say, you know what, my running total is an integer. And I'm going to take an integer for my starting value that I will initialize total to. And my plus equal will return an integer. Now it's going to take a person, and it'll return total equals total, but I can't say plus t because you can't take an integer and add a person to it. So here's where I'll call get number. And notice the compiler understands that t is a person and gives me IntelliSense here. So I can call get number. And then my get total will return an integer. All my red wigglies have gone away. I'm going to take this const out of here, and I'm just going to ask you to trust me. I told you that it had to be there for when people passed constants like 3. There isn't such a thing really as the equivalent of a literal person, and at the moment it wouldn't compile if I left it in. When we get to the const material, you will understand why, and that's not very far away, so trust me. So let's go back to the main now. We don't need this fake person for start purposes, and I can actually just pass in the starting value that I want of 0, make a couple of people, and now I can accumulate those people. Now people is of type integer rather than person, so I don't need to call get total. Or I do need to call get total, but I don't need to call get number on that. So I can just do this. See, we have no wigglies, but I will build it just to confirm. Build succeeds. Now let's run it. 10 and hello world are from our old demo. They still work. And you notice it's also now printed out 579. If I look at my two people, 1, 2, 3 plus 4, 5, 6 is indeed 579. So we successfully accumulated these two people, building up an integer running total, and which we were able to print out. It really wasn't hard to write the specialization for person. When the day comes that you need to write a template specialization, you know how. And if you find yourself arguing about whether or not template specializations need to exist, you've seen an example of what they can be good for. Templates are really not that scary, and they are one of the things that makes C++ such a high-performing language for you to write applications in. They check what's going on at compile time. When you try to put an inappropriate type into a collection or add it to a running total, The compiler complains, not at runtime. So you can't execute the code that has the problem that's violating type safety. And at runtime, there's no need to check. It wouldn't have compiled if it wasn't a type-safe behavior. That's why your application can be so fast when you use templates. But the productivity is really pretty dramatic. As long as your types are compatible with the templates you're using, it can really package up, well, just about everything you learn as an undergraduate. And in some cases, you barely even notice that you're using the template. If you happen to have a type that doesn't work with the template as written, because you're missing an operator, because you're missing a member function, because your template is special in some way, then you can provide an operator if that's appropriate, or write a template specialization and handle the special cases of your code that the person who wrote the template didn't know was coming. Now, despite the fact I wrote templates in my demos, you are not going to start by writing templates. You're going to start by using them. I let you see them being written so that you understand they're very simple and they're not that magical. The power is really in the language feature, not in the fact that someone went and wrote a 1,000-line template. That said, the templates in the standard library are more complicated than the super simple ones that I showed you. They work with special edge cases. They check for errors. They understand that sometimes additions might overflow or other unusual circumstances might arise. Using a template saves you a ton of development time, whether it's for collections, whether it's for algorithms, whether it's for simple mathematical transformations. You shouldn't be writing that code. You're hardly the first person who ever came across the idea of, well, we could have a hash table. Obviously, any code you don't have to write but that you can count on working is a big benefit. So with templates, you get that library power without taking a performance hit. They are probably the best thing about C++ when you compare it to other languages.